Hello, everyone. This is Dr. Jang, and my class is doing a group project, and we have our group lead, and everybody's here, and we call ourselves the E-bar MeMo team. So electricity bar, mechanical motor. So we have been doing this for about 10 days. We're going to share our experience of designing our drone, which is a heavy-duty drone. We target about 5 pounds payload. And for those who been doing this before, the 5 pounds payload, it's the same as Amazon's delivery drone. So we're pretty aggressive, and our budget is about $500 US. And so we are at the end of first cut, and we're gonna run another 10 days after this one. So far we are 10 days into the project. So we're gonna have 2 rounds of kind of going around the table, and my students, try to smile and just be honest, sharing your knowledge. So we're gonna go from the electrical team, and so Tej, and then Jason, and then Tony is the motor lead, and then Sophia is the battery lead, and then so we're gonna go around like a clockwise, okay? All right, so Tej, why don't you introduce yourself, and then followed by Jason and Tony and Sophia, okay? All right, go ahead.
Okay, my name is Tej Andari, and I'm a senior at Pacific Academy Irvine and taking AP Physics 2 and with Dr. Jing. And so my main role in this project is to be the electrical lead. And more specifically, the 2 parts I'm kind of responsible for is the FC, which means flight controller, which is kind of known as the brain of the drone, and then the ESC, which is like controlling the speed or rotation of the motor, which is the electronic speed controller. Yeah.
Okay, Jason.
Hello, my name is Jason, and I'm also in 12th grade, and I'm also taking AP Physics 2 this year. I'm the mechanical lead and particularly responsible for the propellers and the frame. I'm also responsible for the major part of the building of the drone, and which includes soldering, wiring, and also making sure compatibility isn't an issue.
Great, Tony.
Yeah, okay. My name is Tony Guo, and I'm the junior in. Okay, so my name is Tony Guo, and I'm in PA as a junior, and I'm in the AP Physics 2, and I serve as the part of the mode stuff, which is motor in a drone. So motor basically just provide an upward lift of it, and it's both combine the electronic stuff and the mechanical stuff. So yeah, that's my role for it, like to make it compatible and effective for our goal to rise about 5 pound stuff to the side. Yeah. So that's what I'm trying to do.
Thank you, Sophia.
Hello, I'm Sophia, and I am a junior this year. I am in charge of the batteries and also our PR kind of like blog page. Yeah, so I have to make sure that the batteries are able to supply enough power to, get the motors powered with enough thrust to lift our drone. And I also have to work with many of the other teammates and understand their parts and how it can be powered by the battery.
All right, so we're gonna skip Eric. So before everyone goes around and talking about their design, the first cut so far, so I'm gonna give an overview of where we are, right? So we started out with the definition of the project being the 5 pound payload. So then we decided, well, we're gonna have about 2.5 thrust to the weight ratio, right? So then the weight is 5 pounds, so we need about 2.5, so that's about 15, right? It's about 15 or 12 to 15 pounds of the thrust. So then that would determine what kind of motor do we need, right? So then go ahead, and Tony would then pick a motor that will give us that much, and then combine with the propeller, right? So once we have that, then we have the battery that tell us that how much of sustaining current that we need. So that then tell us it's going to be a 6S type of battery. And so once we have that, Then we also go to the mechanical lead, and then he will then determine what is the length. So then that will tell us the area. So that will create the thrust that we needed, which would then, push up the drone from the rest position. Okay. And, the FC is always needed, especially when we are in the air. So FC will then using the gyro to help us to maintain the position, the equilibrium position that the transmitter and the receiver determine. So that's the overall of pictures of where we are. So at this point, we're going to ask going to go around the circle clockwise again, and Tej will go ahead first. Well, the electrical side. Tej, go ahead.
FC.
I cannot hear you. Yeah. Repeat again.
Oh, so for the FC flight controller, I think you can see in the picture behind me, it shows the FC on the top, and underneath is the ESC, which is once again the electronic speed controller. So these two like work directly with each other, but most of the computing and program has to do with or lays within the flight controller. So one of the main program kind of language almost that is mainly used is called Betaflight, and we will probably use something similar to that. And so this flight controller can, like Dr. Jing has said, like kind of make sure the same position is kept, and also tell which motor needs to be like spinning faster than the other, so it can turn, the drone can like turn towards the right or towards the left. And for our particular choice, we kind of chose one that's an F7, means like it's kind of a newer generation compared to F4 and also F3, which F3 and F1 is not really produced anymore. And F7, since it's newer, it is like slightly more pricey, but we also need to make sure that the ESC is still compatible with such a powerful motor, so that it can like have a higher speed setting to make the like motor useful. And then
30 seconds, okay?
Oh, okay. And then I think just one more thing is that to keep make sure everything is safe, we also have a heat sink on the ESC to keep the temperature a bit lower. Yeah.
All right. So thank you, Tej. So we're going to go to our mechanical lead, Jason, and he's going to talk about the propeller and the frame and the other stuff.
So for my part of the project with the frame, we have chosen the iFlight XL10 V5, which is a 10-inch FPV frame. And this was also recommended by our previous physics student, Eric. The good thing about this frame is it can handle a lot of weight. So because it is a 3K carbon fiber airframe, so no matter, as long as it is not an extreme increase in weight for our drone, the frame should be able to handle it. It is also compatible with the flight controller because it fits both 30.5 times 30.5 millimeter and 20 times 20 millimeter stacks for the flight controller. Another good thing about this frame is it's an X design, so it makes it simple instead of a H design, which is also a choice that we thought about. But we landed on the X design because this is our first drone project, and we want to keep the control of each of the 4 propellers simple. And for the blades for the motors, we have chosen the HQ Macro Quad Prop, which is a 10 by 5 by 3 propeller. And the reason we chose this propeller is it is able to fit in the frame. But there's still a reason that there's still testing that we have to do in order to determine if it is safe or not. The reason for this is the maximum dimension or the length for the propeller is 10 inches. So, and the maximum rated propeller size for our frame is also 10 inches. Although this would work, we would need to see if it is viable or not. However, with all of our choices, this is looking to be the best propeller. And one last thing I want to emphasize is this propeller's material is using a glass fiber reinforced nylon. So we would need some extra backup propellers if some of the propellers break.
Okay, thank you, Jason. And we'll then go to Tony, our motor lead.
Okay, so I'm Tony. Okay, so I'm Tony. I'm motor lead and the motion control, and my choices V3008 and 1155 kV motor. So there's two main number in there, which is represent the dimension of it and kind of electronic stuff on it. So basically, it just ensure like basically represent two stuff, which one is about the electronic stuff and another is the mechanical stuff, which is motors do. And our goal is kind of lift a very heavy stuff. So we need a little bit better torque. So as we know, if we fix the power is also equal to the torque times the RPM, don't necessarily in RPM, but the angular velocity. So if we have a lesser RPM, we will have a stronger torque to lift it up from the ground to the sky. I'm pretty excited. And this kind of stuff is determined by the kV, and the kV represent like if we have one voltage, like 1 volt, we will have, for example, in this case, we will have 1155 RPM per, rotation per minute. So compared to other kind of higher kV stuff, it have an advantage like better torque. So it will eventually contribute it by the maximum throw, it will contribute about 3 kilograms per motor, so pretty big. So if we use this kind of motor, we will contribute about 7 kilograms, which is slightly bigger than our overall goal for our acceleration according to the Newton's second law. Yeah, so yeah, that's why I choose the motor, and it is compatible to the battery because the voltage it requires around. Yeah, so that's all I got. Thank you.
All right. Okay. Well, thank you, Tony. And then we go to the battery lead, Sophia.
Hello. So currently we have been considering the Z motor, so ZEEE brand. And then we know for sure that we want a 6-cell LiPo 22.2 volts battery. Right now, we're still not sure how many amp hour we want for the battery, because according to the motors that we are using, right, I think we will need at least about 6 amp hour to fully power all 4 of our motors on the drone. Yeah, so we are looking at many different options because the amp hour multiplied by the 22.2 volts is what is going to determine our final power, right? So our power is going to be directly proportional to this amp hour value. I think 2 of the things that we are currently considering, number 1 is to just get a larger battery. So this will be about 84 grams, so definitely heavier. But this can, one battery just supply us the 6 amp hour that we need. Although I have been also told that that might not be the best fit for drones. So a second option that we are considering is to connect many 1.3 amp hour batteries in series, because batteries in series, right, their total amp hour will add up if you connect them that way. Yeah, so I think if we were to do that in series, we might need more batteries in series, for instance, like 3 or 4 batteries if we can fit them. One last thing is the discharge rate, or the C rating for each battery. I think we will definitely need a higher C rating, about like 100 to 120, because we have a large amount of current that will have to be drawn from the drone. And we need to be able to quickly charge up each component of the drone. Yeah, so I think that is also something that is very important to think about.
Okay, well, thank you, Sophia. So Sophia will also be leading our blog, which is very important for our communication. So finally, I'll sum it up. I think our most important two things that in my mind may not be agreeable with everyone, but in my mind is number one, payload. And that drives almost everything. And then number two is our compatibility. Okay, so from the payload and the compatibility, you can see the principle that we are driving on is number one, we have ballooning equation. The ballooning equation is the energy conservation principle. And I don't want to talk about the formula of it, right? But I think if you study it, you should know. And so then that drives the mechanical design. And that drives the fluid dynamic design, that drives the motor design. Okay. So then we have the Newton's second law for the rotation. So that's also the mechanical design, and then also the motor design, and also the the moving inertial design. And then we also have the mth hour, right? So mth hour of the battery tell us that how long can we actually sustain in the air in a certain kind of RPM in that kind of payload. So the m hour of the battery is telling us a lot, all right? And then we also have one more thing that I forgot. I think, what else, guys? Anything you can remember? What else do we need to know in terms of principle? Anything else that we're missing? Well, we also have the three-phase, right? The three-phase is coming from the magnetism, right? So that you have the electromagnet, we also have the permanent magnet. So then that will be energizing different phase, and then that would then push the rotor to turn to the direction that you want it, right? Yeah, and then the other one will be the PWM. So the pulse width modulation determine the duty cycle. And the duty cycle larger will give you the higher current, and then we're driving it faster, right? And then on the controller side with the PID control. So that's the PID theory. And so people who study control would know that goes into the FC's firmware, right? So the FC's firmware would then implement this PID with a certain bandwidth. So the higher the bandwidth, the better the performance. And you can also control the stability, right? So that means that using gyro to give the sensor feedback. And the actuator here is your motor. So you have 4 motor. So we are quadcopter, and then we have 3 sensor, which is gyro, right? We don't have the GPS, and we may not actually also including FPV, right? So FPV is supported by the flight controller. So the flight controller that we chose is F7. Actually, is capable of supporting the FPV, right? Okay. And so in terms of receiver and transmitter, so those two, we tend to want it to be from the same company. So that will be compatible. And on the flight controller and also the ESC, we also want it to be kind of together. So that way, the compatibility on that side is also a little easier. So then what we left with is from the propeller to the motor, right? And then from the receiver to the FC, and from the battery to everyone else. So for the battery, we need to think about the connectivity, right? How does the power get to everybody, right? And how is the power distributed, right? So that is the overall concept that we are using to drive our design. And I think the key point here is for students to feel they each has a role and they are engaged in design. And they are learning as we go, and everybody is raising questions to each other to know what his role is and what he needs to know in able to make sure the compatibility is being satisfied. So I think we all have a very good humble learning attitude. And I'm very grateful to have a team like this, and we all can share, and we all working hard daily. And we've been doing this for 10 days full-time in the classroom. So we actually stopped preparing for the AP test. We just full-time doing this project here. And we probably have about another 10 days. And by that time, we should have our parts arrive and we'll be ready to break something, right? Right? We're ready to break it, right?
Yeah.
Whether it will pop or it will actually comes up. So I tell them that if they can come up like, 1 meter with 5-pound payload and then safely go down, then that's 80% grade, right? So if you can fly up 1 meter and then in the back parking lot and would actually fly in, let's say 1 meter per second across the back parking lot for 10 meter, and then it landed safely and we, release the package of the 5 pound. And I think that would be an 8, right? Okay, so let's see what happened. And so with that, that's all I have. So maybe we'll give anybody who want to have the final words. We have about 1 minute left. So whoever want to, just share something that you feel like what do you think about the project so far? How does it go? Everybody has 10, 15 seconds. Do you feel like you enjoy it or you hate it, or, like it's too much work? Or what do you think? It's too overwhelming? Or, it's hard to communicate. It's hard to know what people are thinking about. So go around the table, just if you have something to say, just go ahead and say it.
Dr. Jane.
Yes.
I think for the battery, maybe 6,000 mAh is too heavy for a 10-inch drone.
Okay. Sophia, right?
Maybe I think Tony and Sophia should talk about it, because Tony is in charge of the motor, which is related to the lift. And if the battery is too heavy, I think, yeah.
About 30 seconds left, okay? Eric, maybe we'll take this one offline, okay? Anybody that want to say something about the feeling so far, then you can say something. We have about 20 seconds. It's going to cut us off. Anybody?
No, okay.
I think it's just like a challenging project that pushed us to be more inquisitive and research on our own, which I really enjoy. Yeah.
That's excellent. Okay. Anyone else? Probably have 20 seconds.
Yeah, I just firstly, I feel very vague about this project, but after research and all the discussion, I feel a little bit clearer and how to do something or something. So yeah, that's my feeling.
I think the time is up. Okay, we're gonna say goodbye. Bye bye. We'll see you tomorrow. Bye.
See you.
Thank you, Eric. Bye bye.
Bye bye.